I guess we can make a start. So I'm going to talk about something more interesting than I did yesterday, although I don't think many of you were in this room yesterday. I'm going to talk about how our optical dissolved oxygen sensor works. This is relevant for most sensors on the market. So most sensors will work in a similar way. This is just talking about how ours works and why we think it's convenient for use in the field. So we have a very small DO sensor. Okay. Just screw this so I can show you. So you can see here we've got a DO stick. Okay, so this is the DO sensor right on the bottom here. Okay, and we combine it with our EC sensor. Okay, which is this with the gold pins. These gold pins are done so because they're better for corrosion, and this is like a pressed-in EC ring, and all of this is completely sealed. Okay, so it stops water from tracking up into the board. So the DO sensor itself is 8 millimeters in diameter. Okay, so it's a very small sensor. I'm just going to unscrew this here and just maybe show you individually the sensors, so you can see the DO sensors isn't there, and that's the actual sensor. It's very small. Okay. So I'll show you how it works. So what that means is we're able to save space in our probes. So some of you in this room, we spoke about the AP2000, this product yesterday. So we can measure 13 parameters in a probe, which will go down to 2-inch monitoring well. Okay, so that is a pretty neat feature, especially if you want to do like depth profiling, or you want to look at different points in the well or different inlets. This probe will obviously go down a 2-inch well. That makes it convenient for you guys. We had to make a sensor that was going to last, was rugged, the cost of ownership was low, it was easy to calibrate, and it was easy to live with. Okay, so a lot of customers I talk to, they tell me that I have to change DO caps very regularly, I have to refill with electrolyte solution. With an optical sensor, you don't need to do that. So you have this little membrane cap, okay, and then this membrane cap lasts for up to 10 years on our sensor. So on other sensors, you might be changing that every month, if it's a galvanic sensor, or you might be changing it every year, depending on which company's products you use. So I introduced Aquaread yesterday. I'll keep this brief so we can get on to the more important parts. Aquaread was started in 2008, so we're a British manufacturer of water quality, multi-parameter instrumentation, and water level instrumentation as well. So there aren't too many companies in the UK that make this kind of thing, and we distribute in the US through Geotech, and those guys will rent, sell, support, calibrate our instrumentation for you. And that's just an overview of the products that we make. So we do a range called the Aquaprobes, which is this. There's a picture at the end I'll show you. We do a range of sondes, which is on my stand, the Pro series, which I talked about yesterday. And we do a range of water level sensors, all of which, as I've said, is manufactured in the UK. So before we get into the science on how the DO sensor actually functions, this is just an overview of the sensors which are available from us. So we have the big 5 parameters, the usual suspects that you would use. All of our probes come with those standard parameters included. So they come on the probe, you don't have to specify them. And then the configurability in our products is you have auxiliary ports. So you have 2 on this, so you can add in 1 ISE sensor and 1 optical sensor. That gets you up to 13 parameters. And then we do bigger platforms, so you can house more of the optional sensors in. So you could have like, I don't know, 7 ISE sensors, although we don't make 7, but you could have 7 optical sensors if you wanted. So, you know, a diverse range of sensing options. Okay. So you can see on screen there, the DO sensor is lit up. So if I was to plug this probe in, which I will do very quickly, you will start to see the LEDs flash, which I'll show you all in a second. So effectively what you've got is in the middle, you've got like a red disc, okay? So that's like a photo detector, okay? So that's reading information, okay? The LEDs are used for the optics. So they excite a gas permeable membrane. So this membrane is actually has a luminopore inside, okay? So oxygen particles can enter this cap. We excite those particles, which slows them down. And then the photodetector reads that slow response, and then through maths and calculations, a dissolved oxygen value is given. This process is called dynamic luminescence quenching. Okay, so it does have a pretty interesting scientific name. Dissolved oxygen to you and I there, but yeah, that is the name. So that's the sensor, and that's the information on how it works. So you can see on here, the LEDs are flashing away. Okay. So when you're using the sensor, that's what's happening. So these LEDs are constantly beaming into this this membrane, which has the luminopore inside, and then they're taking readings all the time. The reading process of the sensor takes 11 milliseconds. Okay, so that's how fast our sensor is. The calibration of the sensor is done in one of 2 ways, or sorry, one of 3 ways. So you can do 100% saturated oxygen calibration, and that process is basically you put the sleeve on, you would moisten a towel, and then you place it over the sensor. That does you 100%. We do a 0 oxygen solution, which is the 0 value, or you can calibrate it using gas. So some customers use gas because it's very quick. So what the calibration process is doing is it will extract oxygen from the DO cap, or it will oxygenate the sample. Okay, so that's the calibration is basically giving a 0 value and a 100% value to calibrate against, and that's the range. The calibration is stored for up to 6 months. So actually you can not calibrate it for quite some time, and it will stay stable. We have scientific research that shows that it does stay, or lab tests that show it stays stable for that length of time. So with a galvanic sensor, which obviously is not optical, they tend to drop off. So you have to regularly change the electrolyte solution. You have to change the membrane cap because they degrade. The reason you have to change those is because that's a chemical reaction. The reason optical DO sensors have become so popular is because they just use light. So the only thing you really need to worry about is the membrane cap. So that's just an expanded view of the sensor I pointed out to you earlier. So you can see, because it's only 8 mm in diameter, we can fit it to our EC stick to save space. So, and on our new Pro Series sonde, we're using the same sensor as well. So, I've already said this, but you've got a long life DO cap. So we have customers that have purchased probes 10 years ago, and they're still on the same DO cap. Why am I making such a song and dance about it? Well, it saves between $300 and $400 a year in cost of ownership. So that's one of the key features that Aquaread tries to get across to customers. Is that the cost of running our probes is generally a lot lower than others. The sensor is very fast, so I said this earlier, but 11 milliseconds to take a reading. So that's 11 milliseconds to reach T90, which is the value given for DO sensors. So So this is our meter. So readings are displayed on this screen. So the purpose to show you this is, or the purpose of showing you this rather, is that the DO readings are compensated for barometric pressure automatically, and they are compensated for EC as well. So with some sensors, you have to do calculations after you've taken readings. Our meter does all this automatically for you. So you can store your GLP data as well. So the calibration data, or how successful your calibration was, can be stored and then recalled, and you can export that information. So if customers say to you, well, I want to know how good your calibration was based on what the manufacturer says it should be, you can extract that calibration data from the meter and include that in your field reports if you need to. Okay. So advantages in the field. So it is highly accurate. Specification is very good. I have it to hand on my stand if anyone wants it. It holds its calibration for up to 6 months, which is pretty good. Saves having to calibrate stuff regularly. Obviously, for some parameters, you have to make more regular calibration, but for this one, you don't. It takes 11 milliseconds to take a reading, so it'll stabilize very quickly, even if it was in the flow cell. You do not need any flow over the sensor either. Okay, so with a galvanic sensor, you need a flow of steady water over it because it's a chemical reaction sensor. This is an optical sensor, so it's using light. So you don't need any flow. There are no special storage requirements either, so you don't need to fit or remember to fit a container over with water inside to keep it moist. Okay, this sensor can just be left dry. Okay? There's nothing in it that's going to degrade or dry out. And it's rugged as well, so it performs very well in sort of applications where there's a lot of fouling, okay, because of the materials we've used. Okay. So that is an expanded view of this probe here. Obviously, I can't keep walking around and showing you guys, so it's on screen. So the 12, it's actually 13 parameters, but 13 parameters in one probe. So you can see that's how we group our sensors together. So by combining DOEC and temperature as well, in one stick, we can give you 13 parameters in a 42 mil probe body. So a lot of customers in Europe do use this probe, so they'll fit it with like a turbidity sensor. They might use like a refined oil sensor if they're doing contaminated land cleanup. They might look at nitrates, ammonia, the usual suspects in terms of the sensors we sell. So they combine all of this, and then they have a more diverse product. That's an overview of our range, or what our range of products look like. So this was included yesterday in my other presentation. So I said about 12 parameters. On some of our bigger probes, you can fit on more sensors. So basically, the bigger the probe at the right-hand side of the screen, that's our biggest probe. So that can hold 6 additional sensors as well as the standard parameters. And right through to our smallest probe here, the AP Lite, which just holds 1 optical sensor. There's a case study on there as well, which we used for the customer used the AP2000 with the optical DO sensors on. One good thing as well, does anyone know the Glastonbury Festival in here? I know David more. No? It's a music festival in the UK. I don't know if you've seen it, but every time Glastonbury is on, they acquire 100 of our optical DO sensors. So, and the reason they acquire those is because as part of their use of the land, so to get the permits, they have to measure DO in monitoring wells. The reason they purchase ours is because it holds its calibration for up to 6 months. So they can stick them in a well on a logger, just record the data, pull it right out, they've got the data. They don't need to do anything with it. It's done. So I finished nice and early ahead of lunch, so I'm not going to keep you from eating food. Any questions? Yes? No?
We both did at the same time.
Go on.
So in terms of data logging
Yeah.
on the meter, you said that you could pull the data off. So how much does it log exactly?
Okay. That's a good question. So is it on here? No. So when you've used this meter in the field, you take it back to the office, okay? You would have taken off your probes, cable connection on the bottom. We do a USB connection, which goes to a PC software. So we do have a Bluetooth app in development at the moment. So I was in two minds whether to actually include this, because it's kind of old technology, but it's still popular because it's running. So you can download the data to 10,000 data points, called 4 data sets. And you can extract that into Excel straight away. So all of the compensated data you can pull out. So as I said, the meter's got the baro sensor inside, which is doing all of those compensations. So you don't have to like have a baro logger or anything like that. And you can pull out the raw uncompensated data as well, if you need it for scientific purposes or whatever you want to do, calculations. Is that good?
So how frequently can the optical video sensor take a video?
Can take readings?
Yeah.
So the fastest logging rate on our sensors is 1 minute. Okay. So and the reason for that is, although DO is very fast, if you can imagine you've got a probe that's full of sensors, they all need to take their different readings. And what happens is if you don't have enough time, they all take milliseconds, it's not very long. But if they're all on at the same time, it just creates mess, creates noise. So each sensor does its thing, then the next one, then the next one, and they just constantly repeat that process. The probes are actually drawing in information all the time. So they're constantly feeding back information to the meter. It's the meter that actually figures out that information. So, a customer in Singapore was like, well, so they go off for a minute and then start again? No. So, because obviously then you would get no stabilization, you'd have really lumpy data, because you'd have like 1 minute stop, 1 minute stop. So they take a long sample of data. We do averaging as well on the data. So for things like chlorophyll, so if you're monitoring like a chlorophyll trend, if you had like window or snap sampling, so where the sensor would be on for so long, stop, on for so long, stop, on for so long, stop, that would cause spiky data. So that's why manufacturers use like averaging, so you can like pull out zeros or high trends in low flow sampling with groundwater, because you're not interested in spikes, you're interested in what the data is actually doing over a period of time. So what we've done with our optical sensors, especially on the Pro series, is those sensors stay on for quite a while, and they give a nice running average of information, as opposed to being spiky. So it was one criticism that was made of Aquaread probably 4.5 years ago. So a customer was using chlorophyll, we didn't have that. So our sensors would come on, take a burst of data, go off, made it very spiky. It actually looked like the sensor didn't work very well, which is a bit worrying for the customer. They would just spend $5,000 on a chlorophyll sensor from us. So we actually worked with a university in the UK, along with our own technical scientists, and introduced that averaging. And DO uses that as well. So the main point of that is the probe is always taking measurements. But 1 minute is the fastest one. It was the long answer anyway. Anybody else? Good. Well, thank you very much. Hope you enjoy your lunch.